Alright, in this video we're going to talk about critical points. Okay, critical points consist of stationary point. Alright, stationary point. So stationary point is a point where the dy dx, or we said the f prime x, or we said f prime x to be equals to 0. Alright, dy dx equals 0 or f prime x equals to 0. This is a horizontal tangent there. Means that there is a, at that point we have a horizontal tangent. Alright, for example, local maximum, local minimum point. So all this is the which you have dy dx equals to 0. Alright, so or some may have inflection point. So which you're not learning in this chapter. So dy dx equals to 0. All of this, the dy dx is equals to 0. Why? Because they're stationary before they turn. So sometimes we name this to be a turning point. Alright, for this type of point we say turning point because they go up, then they're going down, then they go down, they're going up. Okay, we thought this to be a turning point. So dy dx 0, all this. Okay, dy dx equals to 0. Why? Because the tangent is horizontal, or we said parallel to the x-axis. Alright, so this case is a stationary point, but this is not a turning point. This is not a turning point because you see they are not turning, they are keep going up. Right, this one going up and going down. This is turning point, turning point, turning point, and this is a stationary, or sometimes we say inflection point, change of concavity. So, but what you need to know is stationary point. Okay, all of this is stationary point where dy dx is 0. Okay, another category for critical point. Critical point also consists of where the singular point. Singular point. So singular point is a point where the f prime x undefined. Undefined, or we said dy dx undefined. Dy dx undefined. So where's the curve have a curves, has a curves. So where there are no tangent, okay, there are no tangent, no gradient, okay, no gradient of tangent. Or we said f prime x undefined, right? Undefined sharp point is a sharp point, right? So f prime, they are not differentiable at this point. So this is also a critical point. Alright, a critical point. This is a critical point. So critical point, you will find out that the graph to be very sharp here, where is usually f prime x undefined. Alright, so there are many more cases involving singular point. Alright, so this is a simple that you need to know. Alright, so in the same video, I'm going to talk about some example involving critical point. You must remember critical point, when they're asking you to find critical point, means that it consists of stationary point and singular point. Alright, f prime x undefined. So there is another point which is end point at which I'm not going to talk in this video here. Alright, okay, let's continue with an example. Alright, let's look at this example. So I'm going to find critical points. As you know, that critical point consists of stationary point and singular point, right? So we find the stationary point. Stationary point here means that the f prime x equals to 0. Dy dx equals to 0, the first derivative. So of course here I need to find the first derivative first. I'm going to differentiate. Differentiate f prime, differentiate fx. So differentiate x to the power of 2 over 3. Right? So you are getting 2 over 3, x to the power of 2 over 3 minus 1. Basic rule, right? So differentiate minus with differentiate 2x, you have 2. So which gives you 2 over 3, x to the power of negative 1 over 3 minus 2, which you were getting 2 over 3 x to the power 1 over 3, right? As this negative you bring down, then you minus 2. So I make this into one fraction, so it will be 2 minus with 6 x to the power 1 over 3. As I multiply with 3x to the power 1 over 3, 3x to the power 1 over 3, right? So then I was getting 2 minus 2, 3, 6x to the power 1 over 3 divided by 3x to the power 1 over 3. So simple, I already find my f prime x, which is in the form of 2 minus with 6x to the power 1 over 3 divided by 3x to the power 1 over 3. So this is a special function, okay, a radical function, okay. So a third function. So now you look at this, you have 2 minus 6x to the power 1 over 3 and divided by 3x to the power 1 over 3. So this is the first derivative of this function. So then we have to consider, by using what we have here, we have to find the stationary point. So we equate that equals to 0, means that we equate 2 minus x to the power 1 over 3 divided by 3x to the power 1 over 3 equals to 0. So this thing will be 0 if the numerator is 0, right? Numerator is 0. So, or you can say this, multiply this, then you can say that 2 minus 6x to the power 1 over 3 is 0, right? So we can try to find the critical point, okay, which is a stationary point in this case. So will be 6x to the power 1 over 3, 6x to the power 1 over 3 equals to 2. So x to the power 1 over 3 is equals to 1 over 3, right? 2, 3, 6. So means that the value of x is the cube root of, which is the cube root of 3, right? So the cube root of 1 over cube root of 3. So I will consider this x as a critical point, all right, a critical number. So where the x will give f prime x equals to 0, right? So of course, to find the coordinates of this point, of this critical point, so you have to substitute inside here, right? You have to substitute inside here. So okay, so how to find that critical point for this case? Then the value of y, this is actually the value of y, right? So you can find this is your x. So y equals to x to the power of 2 over 3 minus with 2x. Where's your x is? X is, if you actually, you can rewrite this thing as 3 to the power of negative 1 over 3, right? 3 to the power of negative 1 over 3. So okay. Oh, sorry, I'm doing wrong here. So where I supposed to okay, something wrong here. So where the cube, all right, okay, let's redo this. So 6x to the power, okay, x power 1 over 3 will be equals to 1 over 3, right? So you want to find the value of x, so you have to cube both sides. Just now I make a mistake. So I cube both sides, then I can getting x. The critical number will be 1 over 27. Okay, 1 over 27. So means that you are getting 1 over 27 is 27 to the power of negative 1, right? 27 to the power of negative 1. So which will be 27 power of negative 1. And this one will be 1 over 27. It's the same. I'm using 1 over 27 for this. And for this one, I need to evaluate. So as I know that 27 is 3 to the power of 3. 3 to the power of 3. So negative 3, 2 over 3. Right? So 27, negative 2 over 3. So cancel out. You will have 1 over 9. Right? 3 to the power of negative 2 is 1 over 3 power of 2. 1 over 9 minus with 2 over 27. Right? 2 over 27. Alright, let's use calculator and getting that point. So which you are getting 1 over 9 minus with 2 over 27. So you're getting 1 over 27. So means that the stationary point for the dy, the first critical point here will be the stationary point, which is your x to be 1 over 27, and your y value also 1 over 27. So this is the coordinates of the stationary point, alright, for this case. So as you know that there is another, this is for stationary point, so there is another critical point consists of two types, stationary point and singular point. Alright, now I'm going to talk about singular point. Alright, okay, let's talk about another point. So this is f prime x equals 0. Another one, the singular point is f prime x undefined. Where's the sharp point? Or there is a discontinuous. So at that point, so this is called a singular point. So how to find this point? Very simple. F prime x is undefined. So if this is a rational function, then we look at the denominator, right? As rational function only undefined when the denominator is 0. So means that 3x to the power 1 over 3 is equate to 0. I equate this to 0 because this cannot be 0, right? So f prime x is undefined. It's undefined when this one is equals to 0. So if you're solving this, you are getting x equals to 0, right? X equals to 0. And this value of 0 is in the domain. Is in the domain. As you see that the domain for this fx, as this is a 2 over 3, 3 can accept any value x. So means x is the domain. The domain is negative infinity to infinity. And 0 is in the domain. Alright, in the domain. And you can substitute the 0 into the equation. Then you have y equals to 0 to the power of 2 over 3 minus 2 times 0. Then you can getting the value of y, right? This is the critical point. Critical point where the f prime x undefined. So you are getting 0 also, right? So then I'm getting another critical point. This 2 is a critical point. This 2 is a critical point. But this is a stationary point, right? It's a type stationary. This is a type where the f prime x is undefined. Okay? So then you have 2 points here. Alright, 2 points here. So, okay, I'm not going to teach you how to drawing this graph as this is advanced level. So I'm going to show you by using Desmos apps. Okay, you should download these apps. Okay, so you're using these apps, Desmos. Okay, so you keep. Alright, okay, you should download and you can check your graph by using Desmos. So very easy. So I'm going to key in this function. They will give you exactly what happened during this point. I will show you. So x to the power, all right. So I key in x, right? X. Okay. So I key in x. Sorry. So you key in x, right? And power of 2 over 3. 2 over 3. 2 divide 3. Okay. I key in 2 divide 3. So then I point. Now I doing minus, right? Minus with 2x, right? Minus with 2x. So I key in 2x. Sorry, x power of 2 over 3 minus 2x. So if you look at here, you can't really see what is happening, right? So x to the power of 2 over 3 minus with 2x. So I'm going to zoom this thing here. If I zoom, you will see, okay, if you're from far, very far, you can see it's like a straight line, right? But actually what happened during this point here? So you see, I already keyed in this equation, x to the power of 2 over 3 minus with 2x. So now I zoom. Okay, I zoom, keep zooming, and I will see what happened. What is happening there? Can you see? From far it seems like nothing, right? So, but when you zoom, you will see something happen as near to 0. If you see that here, zoom again, you will see something had. This is a cusp, C-U-S-P, right? 0, 0. Can you see or not? 0, 0. The f prime x is undefined. Means there are no gradient at this point. If you look at this very sharp point here, if I zoom, keep zooming, wow, you have even more details. This is a very good apps, right? So 0, 0 is a sharp point. So if you see, so where is 1 over 27? 1 over 27 and 1 over 27. So I can tell you that it's this point. It's this point. It's somewhere around here. Okay? Where there is a dy dx equals to 0 here. Okay? A horizontal gradient tangent, the dy dx equals to 0. So which is 1 over 27, 1 over 27. They're not going to show here, right? So you have to go to very detail. Okay? So you know that there is a stationary point. 1 of here is a stationary point, which is 1 over 27, 1 over 27, and 0, 0 will be a sharp point. So where's the f prime x undefined? And this 2 is considered as a critical points. Alright, I hope you understand. Okay, I will explain more about critical points in the next video.